Hello, and welcome to the Excerpt. I'm Dana Taylor. The story of the American alligator is one of survival. From 1967 to 1987, they were officially listed as an endangered species. But the wetlands of Louisiana, Florida's Everglades National Park, and many other southern habitats are now teeming with roughly 5 million alligators, and their story continues to evolve. Recent studies suggest alligators shape how carbon is stored in soil. Could alligators be an unexpected ally in the fight against climate change? Here to share insights from his recent study published in Nature is Christopher Murray, Associate Professor in the Department of Biological Sciences at Southeastern Louisiana University. Thanks for joining me, Chris.
Of course. Good morning.
Before we tie your findings to alligators, what story unfolded when you looked at soil in areas populated by alligators?
Yeah, so the story that we sort of uncovered was really interesting to us and a little bit surprising. What we found was a correlation, positive correlation between alligator abundance and carbon sequestration in specific habitats. So what that effectively means is where we have more alligators, right, from small populations to much larger populations, we actually see a positive relationship, positive correlation between alligator abundance and carbon sequestration. And this is purely correlative at this stage, right? But what this essentially rests on is trophic cascade theory. Trophic cascade theory sounds a little nerdy, right? But what it essentially means is that where we have more apex predators in the habitat, they do a better job at eating the things that eat the plants that do the carbon sequestration. That trophic cascade theory, of course, is not my work. It's been thrown around in really high-end journals for some time. I read a paper by Dr. Tricia Atwood at Utah State in Nature Climate Change and kind of got the idea, hey, I wonder if this blue carbon marine hypothesis will sort of show or tell the same story in our tidally inundated coastal wetlands with the American alligator.
And speaking of wetlands, what's the potential climate impact here if the wetlands they inhabit dry out?
Really, the issue isn't them drying out. In the case of Louisiana, the issue is actually them sort of going underwater. Louisiana is one of the states where we see very rapid rise in sea level associated with climate change. But what's interesting is that our tidally inundated wetlands are one of the most critical and effective carbon stock habitat in the world, with around 40% of them actually persisting in coastal southeastern United States. So what we have here is a situation where we've got really good habitat for carbon sequestration and an apex predator that, at least at this point, correlates with higher carbon sequestration rates in that habitat. So the ramifications from a conservation or environmental standpoint are pretty serious in my eyes.
Prior to this study, what was already known about how alligators reshape the land and water around them?
Most of the work on ecosystem functionality in the context of the American alligator actually comes from the Everglades, like you mentioned. We know there from a lot of work from a lot of other alligator biologists, really good work in South Florida, that they actually do sort of environmental mechanical engineering, right? They orchestrate these wallow ponds where when the Everglades is dry during the dry season, these ponds that alligators actually help construct hold water and serve as aquatic refugia, a place where animals that need water and plants can go to seek water during harsher periods of the season.
What do you think would happen to those ecosystems if alligators weren't there?
Yeah, see, that's the interesting thing where science sort of comes into play here. Right now, I mean, speaking about simply Louisiana and other coastal tidal wetlands, really talking about not the Everglades, we have correlative data, right? So our next task is to prove causality. This is a lot of nerd talk, but this is how science has to work, right? We have a relationship right now, a pattern right now that we see. Now, the next stage is to say, okay, alligators are causally responsible for the effect that we saw when we looked at the correlation in the paper that you're referencing. So if alligators aren't there, my hypothesis, right, is that carbon sequestration rates would lower right? Meaning more CO2 would be emitted into the atmosphere. Or in the case of the Everglades, maybe we wouldn't get these aquatic refugia, these water islands that animals can go to. And we may see losses in biodiversity in that context. The other thing about Louisiana and other tidally inundated coastal wetlands that are inhabited by the American alligator is what happens to all these invasive species when the alligators aren't there? Feral hogs, right? Or nutria rats. These things are really good at eating plants. So my hypothesis is that if alligators all of a sudden vanished, right, we would get high populations of these herbivores that eat the plants, and we may see decreased carbon sequestration in those areas because the plants that are good at sequestering carbon are being eaten by things that really aren't participating very well in ecosystem functionality, um, potentially more harm than good.
Chris, was there anything in your research that surprised you?
My original hypothesis was that, well, where there's alligators, we're going to see more carbon sequestration as a function of trophic cascade theory. Looking back on those data and finding that there's no difference between where alligators naturally persist and where they don't, places like Maryland, Virginia, Massachusetts, it became obvious to me later on that there's a different apex predator that is working in those habitats, right? So originally I was surprised by that finding, but looking back at it, just having a cursory understanding of ecosystem functionality and community structure, there's a different participant outside of the alligator's biogeographic range. So surprised me initially, but then it was sort of a no duh moment.
I want to turn now to the commercial alligator industry. There was a time when the American alligator was near extinction. Can you take us through the journey of protecting the species from extinction to having an industry that sells alligator meat and hides? How is this a success story in terms of conservation?
Yeah, and it's interesting. I'm a conservation biologist, right? I'm an ecologist. I do some evolutionary biology. And to kind of think that someone in my profession would lean on or at least be positively influenced by an industry, I think is a little bit of a unique phenomenon. But what we saw and what we continue to see is that the natural resource of the American alligator not only saved the American alligator from extinction, specifically, here in Louisiana, I can speak to the best. It saved the American alligator from extinction, from harvest, recreational harvest that really had no limitation, that dwindled numbers way, way down to a dangerous degree, especially from a genetic standpoint. What we saw was that biologists and governments put together a strategy to monetize a natural resource. And what this ultimately culminated in was one of the most effective ecological head starting programs that really has ever existed. The system functions by taking eggs and incubating them, and then returning a portion of the population at a head started age or size. We see this a lot in endangered species where we like to take some animals that are used in the laboratory to breed, and then we raise them up to a degree where their survivorship is a little bit enhanced, and then we re release them. Well, what happened here in Louisiana and across the Southeast was that this head starting program became part of the economy, right? And it continues to be part of the economy. Where what we see is we have the exact same structure, right? Eggs are taken, they're hatched out, they're raised up to a size, and a portion is put back. This not only saved the American alligator from extinction, but as some of the research that we're talking about here today, it actually may have far broader environmental positive consequences that we're just now beginning to look into across the broad range of the American alligator.
I was hoping to see drone footage of your team at work in the field, but there's a reason why it isn't widely shared. This can be dangerous work, and others shouldn't be enticed or encouraged to attempt to do what your professional team does. What can you
Right.
share about how you prep for doing work out in the field?
The one thing I need to do is learn to not wear shorts. I have a tendency to wear shorts in the field. and my legs come back all scratched up every summer. So that's something that my team, specifically me, is working on navigating. But the prep for the team, it sort of depends on the job. If we're interested in doing some nest monitoring work, the first step is finding the nests, right? And that can actually be really challenging across a vast wetland landscape. Then we have to get to the nests, and that's perhaps the most challenging part. Um, the wetland is a dense jungle of phragmites and different types of grasses with some tree hammocks, and it can be very thick. So we essentially just utilize boats to arrive through navigable waterways as close as we can get, and then we walk. Most of our drone footage is actually from trying to guide the person walking to the nest in a habitat that they can't see more than a foot in front of their face. Um, it's a lot of fun, but it can get pretty hot out there.
Chris, what are your hopes regarding what your future research may prove in terms of climate change if alligator populations and the wetlands where they reside are properly protected?
The word prove is an interesting one, right? I think that's the next step, and that's my next hope, is to conclude some type of causality and test hypotheses from a causal perspective. Alligators are causing these ecosystem processes to occur at higher capacity or higher efficiency or higher rates. So my hopes are that this correlation that we've published leads to a better scientific understanding of what alligators do for the environment from an ecosystem scale perspective. And I think in doing so, what we're actually doing is sort of telling chapter 2 of the alligator story, right? There were biologists that created the alligator industry to save the American alligator, and that worked. What I'm interested in doing with crocodilian colleagues around the US is to think about, okay, what else are alligators doing? And highlighting and elucidating to science and to the world that alligators are really important in ecosystem functionality. They're a good thing to have around, potentially in the face of land loss or climate change and other metrics that are important to us from a conservation perspective, like biodiversity. So, my hope is to be able to share to the world and to science and to the public that alligators are not nuisances, right? Alligators are not scary, right? Of course, they command respect, right? They can get big and they can hurt, but it's better to mitigate human crocodilian, in this case, human alligator conflict, than it is to remove a nuisance because these animals are keeping the world a better place for us all to live in potentially. So, putting that story together in summary is my hope.
Chris, it's wonderful to talk to you. Thanks for being on the excerpt.
Of course. Thanks so much, Dana.
Thanks for watching. I'm Dana Taylor. I'll see you next time.